All right, here's your review on graphing radicals. So, if I want to graph a square root function, let's talk about the steps I would do to graph this function. So first I'd recognize what a, h, and k equal. So a is 2, h is positive 1, be careful there, the sign does change, and k, the sign stays the same. Now, hk is where my graph starts. So I'm going to start at 1 and 3, and that's where my graph starts. Now I want to find two more points. So if I think of the parent function, just the square root of x, what other numbers do you know the square root of? So I know the square root of 1 is equal to 1, and I'm going to change it. And I know the square root of 4 is equal to 2. So those are the 2 points I'm going to change. And now how am I going to change it? So h changes the x coordinate. So I'm going to add 1 to the x coordinate. So 1 plus 1, that's 2. And then the x coordinate here, 4 plus 1, that's 5. To change the y coordinate, this requires both that vertical stretch and that vertical shift. So I'm going to multiply first and then add 3. So 1 times 2 and add 3. And then 2 times 2, which is 4, plus 3, which is 7. So I'm going to have to make sure I go high enough here so I can get those points included. So 2, 5. And was it 5, 7? 3, 4, 5, 7. 1, 2, 3, 4, 5, 6. Up there. And then what does the graph look like? So it looks like a curved arrow with an end point or starting point, and it curves up in that direction. If I ask you for the domain, that starts with the h value. So it's going to go 1 to infinity. If I ask you for the range, that's the k value. So it goes 3 to infinity. And if I ask you for the end behavior, so the right end is written as x approaches infinity, and the right end, f at x, is going up forever, and the left end is going to the starting point, hk. So as x approaches 0, the function approaches 3. That's it. So this is a square root function for review of how to graph it and how to analyze it. The other one we need to know is the cube root function. So here's an example of a cube root function. Step 1 again is I'm going to write down what a equals, what h equals, and what k equals. So a is negative 3. Not only is that a vertical stretch, but that's also a reflection because a is negative, so it's going to reflect down on the x-axis. H is negative 2, be careful, and k is negative 1, so the sign doesn't change. Now hk is where my graph is going to start, just like before. So I'm going to start at negative 2, negative 1. That's called the point of inflection for a cube root. So at that point, it's going to change from concave up to concave down. But we do need a couple other points. So from the cube root of x, the cube root of 1, what number 3 times itself is equal to 1? The answer is 1. And I'm going to change it. So I'm going to subtract 2 to the x. And then to the y coordinate, I'm going to multiply and then subtract 1. So 1 times negative 3, and then subtract 1. So negative 1, negative 4 is on my graph. And then the second one, you can take the cube root of a negative number. So what number 3 times itself is negative? So that's going to be negative 1 times negative 1 times negative 1. So that's the other point we need to change. So again, we're going to subtract 2. And then I'm going to multiply. Now a negative times a negative is positive 3. Take away 1. That's 2. So negative 3, 2. And then the last step is, what does this picture look like? So from the point of inflection, it's going to curve down to the right and curve up to the left. And it's going to have that curve to it. The domain and the range never change. The domain and range is all real numbers. So it can be any negative, 0, positive. There's no restrictions. And then the end behavior looking off the graph, the right end, because of the reflection, the right end is going down and the left end is going up. And there you have it. Good luck. I hope that review helped. Mr. G Math, over now.